Hi guys, I want to take some time to refresh our memory on some of the angle relationships we have when lines or parallel lines are cut by a transversal. So if we take a look at some of the names that we have over here on the right side, alternate interior angles, alternate exterior, corresponding angles, same side interior angles. When I hear the word interior and exterior, it always reminds me of a car. So what I like to think of here is I like to take my two lines that are creating all these angle measures, and I like to turn them into a car. Let's see, let's bring out some yellow. We'll put some headlights up here and up here. And we'll put some tail lights in the back, right? Yeah, good. All right, everybody see my car? So with this, the angles that are inside the car would be angles 3, 4, 5, and 6. So 3, 4, 5, and 6 are interior angles. And the angles that are outside the car are 1, 2, 7, 8. So whenever you're looking for things like alternate interior, alternate exterior, that takes your pool of 8 potential angles and it shrinks it down to 4. So then we can take the first part of that word. So if I'm looking for alternate interior angles, what alternate means is I'm on opposite sides of the transversal. The transversal is T because it's the line that intersects two other lines. So if T is the transversal and I want alternate interior angles, I'm looking for the angles that are inside the car but on opposite sides of the transversal. So in this case, one pair would be angle 3 and angle 6. Angle 3 is on the left side of the transversal. Angle 6 is on the right side of the transversal. The other pair of alternate interior angles I have are angle 4 and angle 5. Angle 4 is on the right side. Angle 5 is on the left side. How about alternate exterior angles? So I'm looking for the exterior angles 1, 2, 7, and 8. And I'm looking for the ones that are on opposite, so alternate, opposite exterior angles, opposite sides of the transversal. So if I start with angle 1, it's not angle 2 because angle 2 is right next to it. Those are a linear pair. We've already established those. We already know what linear pairs are, so it can't be 1 and 2. I'm looking for the opposite side of the transversal on the other side of the car. So in this case, it's got to be angle 1 and angle 8. The other pair that we could point out were angle 2 and angle 7. Okay, how about corresponding angles? Corresponding angles are the ones that they don't come out and tell you. Corresponding angles are the ones they kind of hide in here. And with corresponding angles, those are the ones that we're looking for. They're on the same side of the transversal, but one's inside the car and one's outside the car. So if I start here with angle 2, if I focus on angle 2, it can't be angle 4. Even though angle 4 is inside the car and it's on the same side of the transversal, angle 2 and angle 4 form a linear pair. We already know what linear pairs are. It can't be 2 and 4. The corresponding angle with 2 is actually angle 6. Angle 2 and angle 6. We could also have, if we go on the other side with angle 1 would match up with angle 5. So angle 1 and angle 5. Let's switch up some colors here. Angle 4 would match up with angle 8. Angle 4 and angle 8. And then let's go one more color switch here. Angle 3 would match up with angle 7. Okay, another way to think of it would be if you were able to take this and just kind of like break this off, like tear it in half right here and place these 4 angles on top of these 4 angles, which angles would sit on top of each other? That's another way to think about corresponding angles. The last one are called same side interior angles. Well, again, same side interior tells you you're looking for angles that are inside the car and on the same side of the transversal. So with same side interior angles, 4 is on the same or is inside the car and it's on the same side with 6, so it's got to be angle 4 and angle 6. And then the other side would be angle 3 and angle 5. Now with this, if these lines are parallel, now they did not tell us that these lines are parallel, so let's throw some arrows in here to establish that they're parallel to each other. So now that I know these angles are parallel, we have certain relationships with these angles. So what we know with 3 out of the 4 of them is that alternate interior, alternate exterior, and corresponding angles, when the lines are parallel, these ones are always, always, always congruent. So these angles are congruent to each other. The same side interior angles, those ones are kind of the oddballs. Those ones aren't congruent to each other, but they are supplementary, which means they add up to 180.